Hi, in this video we're going to learn about properties of logarithm. At the end of the video, you are expected to be able to learn how to use product rule for logarithms, quotient rule, power rule, and use the said properties to write alternative forms of logarithmic expressions. Let's begin with your properties. The first property is product rule, quotient rule, and power rule. Let's take first your product rule. In the definition says here, if x, y, and b are positive real numbers where b is not equal to 1, then logarithm base b of x times y is equal to logarithm base b of x plus logarithm base b of y. In other words, the logarithm of a product is the sum of the logarithms of the factors. When you have a multiplications of two or more terms, or if the number can be factored, you can split the factor with a plus sign of the same logarithm. Let's have your example. Use the product rule to rewrite each expression. Assume the number is greater than 0. Logarithm base 4 of 3 times 5, so we can separate 3 and 5 with a plus sign of the same logarithm base 4. That's it. Logarithm base 4 of 3 plus logarithm base 4 of 5. Next example, you have logarithm base 5 of 2 plus logarithm base 5 of 8. This time we're taking the definition backwards. If we can separate a factor by a plus sign, we can actually multiply these two, 8 times 2, by taking the property backwards. So you have 2 times 8, which is 16. So you have your final answer, logarithm base 5 of 16. Another example, you have logarithm base 7 of 7 times n, so you just separate 7 and n of the same logarithm. Okay, one more example. Oh no, you have your logarithm base 7 of 7 is actually equal to 1. You just watch out, there are parts that needs to be simplified, so just be watchful. Next, you have the last example of the product rule. What if you have n raised to 4 with a logarithm base 3? What we can do is we can factor n4 by multiplying n to itself 4 times by expanding. And so we can actually separate each n's with the same logarithm base 3 by applying your product rule. And there's a different way of simplifying this. Since it's a repeated four times of logarithm base 3 of n, we can write 4 at the front and write once the logarithm base 3 of n. And that's the final answer. What you need to notice is that maybe we have 4 as a power can be written as a shortcut in front of logarithm. And actually, that's the power rule, which is the third property. It was just shown here that the product rule was used to explain that property. I will mention that again if we get there. Let's have your second property. Your second property is the quotient rule. The same starting point. If x, y, and b are positive real numbers where b is not equal to 1, then logarithm base b of x divided by y is equal to logarithm base b of x minus logarithm base b of y. In other words, the logarithm of a quotient is the difference between the logarithm of the numerator and the logarithm of the denominator. If it was multiplication, it's a plus. Since it's the division, it's a minus. Let's have your example. Use the quotient rule to rewrite each logarithm. We have logarithm base 5 of 3 over 4. Of course, we will just separate of the same logarithm base 5, 3, and then logarithm base 5 of 4 with a minus sign in between. That's quotient rule. Another example, this is the backwards. Since this is a minus sign, we can have 7 over n of the same logarithm base 3. For the condition that n cannot be 0, otherwise this is undefined. Next, letter C, you have logarithm base 4 of 64 over 9. We are going to separate 64 and 9 with a minus in between. So you have logarithm base 4 of 64 minus logarithm base 4 of 9. Again, be watchful. This is possible to evaluate. You have logarithm base 4 of 64. How many times 4 is multiplied to itself to become 64? It's 3. And that's your final answer. Okay, this is the quotient rule. Now, there is a quotient. This is all about the product rule and quotient rule. There is no property of logarithms to rewrite a logarithm of sum or difference. For example, we cannot write logarithm x plus y. There is no definition. It's only for the multiplication or division. Here, you have here logarithm base b of x over y. It is not correct to write them as a separate logarithm. Remember, the property says the logarithm base b of x over y is equal to logarithm base b of x minus logarithm base b of y, not division. This is incorrect. There's no way you can simplify this. There is no way you can write it this way. That's the word of quotient. We are now on our third and last property of logarithm, which is the power rule. If x and b are positive real numbers where b is not equal to 1, and if r is any real number, then logarithm base b of x raised to r is equal to r times logarithm base b of x. In other words, the logarithm of a number to a power equals the exponent times the logarithm of the number. As a shortcut, the power can be written in front and it will be multiplied to the value of the logarithm. Let's have example. Logarithm base 4, logarithm base 5 of 7 raised to 4. To rewrite it applying your power rule, the 4 is just written in front. So you have 4 times logarithm base 5 of 7. Another example, so you have logarithm base b of x to the power of 3. Very simple. 3 will be written in front, so here it is, 3 times logarithm base b of x. Next, if you have a radical expression, what you can do is to rewrite this into exponential, rational exponent, power over root. So you have logarithm base 4 of x to the power of 8 over 3. 8 is power, 3 is root, power over root. And now, since this is the whole power, we can write it in front of the logarithm according to the power rule. And that's it. You have the final answer, 8 over 3 times the logarithm base 4 of x. That's your power rule. Now, we can combine all the properties to write alternative forms of logarithmic expression. Let's have example. You have logarithm base 5 of 5 times x raised to 7. So remember, this is multiplication. We can apply your product rule. You can separate them with a plus sign of the same logarithm. So you have logarithm base 5 plus logarithm base 5 of 5 plus logarithm base 5 of x raised to 7. Now, if we can actually evaluate this, this is actually 1. 5 raised to 1 is equal to 5. So the logarithm value is 5. It's 1. This one, it's a power rule. We can write 7 in front. So here it is. The first part is an evaluation. The second part is power rule. And that's the final answer. Let's have another example. You have logarithm of the cube root of a over c. Remember, we can rewrite the cube root into rational exponent 1/3. Because there's no power, it means 1, root is 3. So the expression is raised to 1/3. By power rule, we can write 1/3 in front. By quotient rule, we can separate logarithm base 4 of a and logarithm base 4 of c by subtraction, which is your quotient rule. The 1/3 stays in front. A and c was separated of the same logarithm with a minus sign according to quotient rule. Okay, that's how you can apply and combine properties to rewrite a given logarithm in its alternative forms. You should have learned how to use properties of logarithms such as the product property, quotient property, and the power property, and use them to evaluate or rewrite alternative forms of a given logarithmic expression. You can watch the video again if you need to review. Thank you.